So it's 2025 winter paper is related to aromatic compounds, like of course OH is attached on the benzene ring, and they're saying which is the equation for the reaction of phenol with bromine water. So we know that OH is 2,4,6 director because it's an electron donating group. When OH is attached to the benzene ring, so it would direct the coming group to 2, 4, 6 positions. What are 2, 4, 6 positions? This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. And we know that OH is EDG. It's an electron donating group. It will direct the coming group to 2, 4, 6 positions. Okay. So, so this is wrong. This is wrong. This may be right. This may be right. Okay. So what's the best option? Since we know this is an electrophilic substitution reaction, we have Br2. One bromine is attached here and here. One bromine is left. Of course, there are hydrogen atoms. This is skeletal formula. We do not show hydrogen atoms in it. So another bromine will react with H to form HBr. So that's why option D is correct, because in option D, HBr is also the product. But in option C, there is only one product. No. We always write down one product when we have addition reaction. This is not addition. Benzene doesn't show addition reaction. Benzene shows substitution reaction. And whenever there is an addition reaction, there would be only one product. So since we know benzene shows substitution reaction, so there should be more than one product. So that's why D option is correct. Question number 2. If benzene has the structure suggested by Kekule, then there should be 4 ice. I told you this one when I was telling you the theory of benzene, if you remember. So there should be 4 isomers of dichlorobenzene as shown. Okay. So now in the correct delocalized model of the benzene structure, there are only 3 isomers. Which 2 Kekule isomers are actually the same? You have 4 structures, and out of 4, you have to see which 2 structures are same. Let me tell you. This is 1, 2, 1, 2, 1, 2, 3, then 1, 2, 3, 4. So 1, 2 dichloro, 1, 2 dichloro, 1 and 2 are same. Option A is correct. Option A is correct. The delocalized model of the aromatic benzene structure involves the overlap of p orbitals to form pi bonds. Okay, I told you this one because in a benzene there are 3 pi bonds, right? And pi bond is formed by the sideways overlapping of the p orbital. This is a weak bond, which can be easily broken down, right? As compared to the sigma bond. So which describes this p orbital overlap to form pi bonds only. To form pi bonds only. Head on overlap? No, it's not head on overlap. It's sideways overlapping. It might be C, it might be D. Sideways overlap, which is in the plane of the ring? No. Sideways overlap, which is both above and below. Yeah, this is correct. Let me show you. Let me show you when I was telling you how the p orbitals are overlapping with each other to form a pi bond. If you can see, this was the structure. This was the structure. You can see above and below the ring. You can see above and below the ring, they are going to overlap with each other and they are going to form a pi bond. That's why option D is correct. Then part B. The delocalization of the pi bonds in benzene results in various properties or characteristics which are different from those expected of Kekule benzene. Which property of benzene is not due to the delocalization of the pi bonds? Number 1, the enthalpy of hydrogenation. The enthalpy of hydrogenation. Okay. So is less exothermic than the value calculated for the calculate structure, and the carbon-carbon bond lengths are all the same. The carbon-hydrogen bond lengths are all the same. All the carbon-carbon bonds give the same infrared stretching vibration peaks. You know, what's the question? Which property of benzene is not due to the delocalization of pi bond? You know, this is your benzene, and delocalization is inside the benzene ring. Inside the benzene ring. So this hydrogenation is related to the delocalization because we add hydrogen atom in it. When we add hydrogen, so the double bond would be finished. The double bond would be eliminated. When they are talking about the carbon-carbon bond length, so the carbon-carbon means it's inside the ring. When they are talking about carbon and hydrogen bond, yeah, this is not inside the ring. It's not due to the delocalization of the pi bond. So option C is correct. Because they are talking about this one. This one, carbon and hydrogen. This is not related to the delocalization of electron. Delocalization is inside the benzene ring. Remember, okay? Delocalization is inside the benzene ring. Or okay, let me send another paper. That's 2025 October paper. वो भी सेम ही लग रहा है मुझे तो. दूसरा भेजता हूँ. Wait. Let me send you another paper. This is 2025. This is 2025 October paper. In this, again, the questions are same. This is June paper. June paper may, if you can see the questions which is related to the benzene ring. So देखो मैंने आपको सारी चीजें यही बताई हुई हैं. बिल्कुल 100% सेम चीजें. कौन कौन से reagents हैं. What's the geometry of the benzene ring, you know? What's the geometry of the benzene ring? All the carbons are double bonded. All the carbons are double bonded to each other. And also we have to see uh, the bond angle between the carbon-carbon atom in a benzene ring, and what are the reagents and conditions for the benzene ring. um, ये क्वेश्चन है, ये जरा देखिएगा. मैं इसको भेजता हूँ पेपर को. यस. पार्ट बी देखिएगा जरा. पार्ट बी. आई एम टॉकिंग अबाउट दिस वन. If you can see this question, which compound is not a catalyst that can be used to form the electrophile for this reaction? Electrophile for this reaction. Yes. Which compound is not a catalyst that can be used to form the electrophile for this reaction? You know, what is this? What is this? What's the product? It's Friedel-Crafts acylation. You know what is this? It's Friedel-Crafts acylation. So if you remember when I was telling you, if you remember when I was telling you different catalyst, we did chlorination. So the catalyst was AlCl3. We did bromination. So the catalyst was AlCl3, AlBr3. We did Friedel-Crafts acylation. We did Friedel-Crafts acylation. So the catalyst was AlCl3. We did Friedel-Crafts acylation. So the catalyst was AlCl3 again. Okay, so they are saying which compound is not a catalyst. So PCl5 is not a catalyst. We can take this catalyst. We can have this catalyst. We can have this catalyst. But we cannot have PCl5 catalyst. You must know these things. All the reagents, all the conditions, all the catalysts. What is the electrophile for this reaction? The thing is that you have to see what is attached on the benzene ring. This is attached, right? It must have a positive charge because benzene is already electron rich compound. It would always react with the positive substance. So if something is attached on the benzene ring, what does it mean? It must have a positive charge. It must have a positive charge. So what's the question? Which is the electrophile for this reaction? So it's very clear. Option B is correct. You know how? You can check the point of attachment. You can check the point of this is the point of attachment. Of course, the positive charge should be present on this carbon, not on this oxygen. Okay, so that's why option B is correct, right? Option B is correct. Okay, simple. C, option D, part D. Which is the structure of the intermediate in this reaction? Let me show you when we were discussing all the intermediates, all the reagents, all the conditions. Let me tell you specifically Friedel-Crafts acylation. That was acylation. If you can check this, that was acylation. See this? 100% same. It was your intermediate. It was your intermediate. So you can check the question what they're asking. Which is the structure of the intermediate in this reaction? This is wrong. This is wrong. Okay. This is wrong. Isn't it? This is wrong because the mouth of this ring should be towards where the substitution is happening. Okay. So there are only two options that might be correct. Option B and option C. Now we have to see which is correct. Now we have to see which is correct. Okay, what do you think? Which is supposed to be the best option? Because it seems that both are correct. But remember, the positive charge should present inside the benzene ring, inside this ring, the half ring, not like that. Option B is correct. These
Sir,
are
why
the
is
small
option D
things that
incorrect?
we must know. Sorry,
Why is D incorrect?
why D is incorrect? Okay, so see this. You can check all the mechanisms, the direction of this one. This should be towards the carbon where the substitution is happening. You can check all the mechanisms like that, like that. Let's suppose I am going to substitute this hydrogen. In the mechanism, it should be like that. Let's suppose I'm interested in this hydrogen. I want to substitute it. In the intermediate, it would be like that. Like that. Remember. So that's the concept. You have to draw the circle, like the mouth of the circle towards the carbon where the substitution is happening. The electrophile is attached on this carbon, on this carbon, on this carbon, on this carbon. So this is wrong. They have inverted this circle. It should be towards this carbon. So that's why option B for ball is correct. Why C is wrong? Because the position of the positive charge is incorrect. That's why it's incorrect. और ओके, तो ये क्वेश्चंस हैं रिलेटेड टू, ये वो क्वेश्चंस हैं विच इज रिलेटेड टू द बेंजीन. अब मैं दूसरा पेपर भेजता हूँ, जरा देखिएगा. इट्स 2025 जनवरी पेपर. इसमें भी हम चेक कर लेते हैं कि बेंजीन से रिलेटेड क्वेश्चन कितने आए हैं और किस तरह के आए हैं. यस. हम्म, ये चेक करो जरा। ओके, मैं सिर्फ बेंजीन से रिलेटेड करा रहा हूँ। यूनिट 5 में इतने सारे क्वेश्चन आपको मिलेंगे यूनिट 4 के कि आप बोलोगे कि एक्चुअल में यूनिट 4 का ही पेपर है, आपको लग रहा होगा देख के ऐसा। और रियलिटी भी यही है। मतलब जो पुराने कॉन्सेप्ट है ऑर्गेनिक के, वो आपको भूलने थोड़ी है, वो याद होने चाहिए ना आपको। सारे रिएजेंट, सारे कंडीशन, इतने सारे क्वेश्चन तो मैं स्किप कर रहा हूँ। वरना तो आपको बेतहाशा चीजें मिलेंगी यहाँ देखने को भाई। पुरानी सारी चीजें, प्राइमरी अल्कोहल, सेकेंडरी अल्कोहल, टर्शियरी अल्कोहल, एवरीथिंग यू विल सी इन दिस। प्राइमरी अल्कोहल को ऑक्सीडाइज करेंगे तो व्हाट वुड बी द प्रोडक्ट, सेकेंडरी अल्कोहल को ऑक्सीडाइज करेंगे तो व्हाट वुड बी द प्रोडक्ट। यू कैन सी दिस क्वेश्चन। दिस इज ऑफ 6 marks. This question is of 6 marks. This is 2025 January paper. This is 2025 January paper, you know. Compare and contrast the bromination of benzene and the bromination of phenol. You can see this when I was telling you in theoretical portion. So I told you that what's the difference between if you are going to do nitration of phenol, if you are going to do nitration of a simple benzene. See the difference. When I have simple benzene, I'm using a catalyst. I'm providing the temperature. And when I am nitrating the phenol, no catalyst is needed, no temperature is needed. Why? It's related to the reactivity, because phenol is more reactive than benzene. So if something is more reactive, it doesn't require any sort of external catalyst. It doesn't require any sort of any temperature, you know. So what they are asking in the question, include equations in your answer. Detailed mechanisms. Detailed mechanism is not required. So this is of 6 marks. So starting from, first of all, you have to think why, like, let's say, let me write down the equation first. Let's suppose if I have, this is the normal benzene and I'm going to brominate it. I'm going, that was FeBr3, or you can use AlBr3, and that would be the product. This is bromobenzene, right? And HBr is also formed. But when I'm going to brominate, when I'm going to brominate phenol, when I'm going to brominate phenol, you know, you know, that would be the product, because bromine is again electron donating group. It would direct the coming group to, oh sorry, it would direct the coming group to attach on 2, 4, 6 position. That would be your final product. 3 moles of are released. So compare and contrast the bromination. You can see when I'm going to brominate this phenol, no catalyst is needed. No catalyst is needed. Remember, no catalyst is needed. Number one thing is that both reactions are both reactions are electrophilic. Both reactions are electrophilic substitution. Okay, both reactions are electrophilic substitution reactions. That's the similarity. That's the similarity. And the reaction is the difference. And the reaction is the difference. Okay. Or I can say benzene requires a catalyst, but phenol doesn't require any catalyst, right? Benzene, catalyst, and heat. But phenol doesn't require any catalyst. And then the thing is that phenol, phenol reacts with bromine at room temperature. Phenol reacts with bromine at room temperature, but benzene doesn't react with bromine at room temperature. We are supposed to provide we are supposed to provide heat. We are supposed to provide heat, remember. So I would say benzene won't react with bromine at room temperature, but phenol will react. Is it? So why this is so? Why this is so? As phenol is more reactive. As phenol is more reactive because lone electron, lone pair of electron on the oxygen atom are delocalized into the ring into the ring as a result of this phenol would be more susceptible towards electrophilic attack. Let's say I have this is benzene ring, right? You can see there are three double bonds, so there are 6 electrons in it. And what if I have this phenol, right? It has a lone pair of electron which is delocalized into the ring. So number of electrons would be higher. It's let's say it's 8 electrons, and they both are reacting. Any electrophile represented by E plus. So which would attract this electrophile more easily? Of course, you will say phenol. Why? Because it's more negative. It has more electrons, and that's it. It has it has more electrons, and that's it. Simple. Okay. So that's why this is of 6 marks. Then they are saying a possible reaction sequence to make procane is shown. Identify by the name or formula the two reagents needed for step number 1. What's going on in step number 1? You must know the type of reaction that we did. Okay, if you remember, it was Friedel-Crafts alkylation. This is this one. See this? This is this one. Friedel-Crafts alkylation, 100% same. 100% same. Methyl benzene. Methyl benzene is foreign. You can see the same thing. So this is of 2 marks. We have to write down the reagent, that is CH3Cl, and also the catalyst, that is AlCl3. Okay. So the reagent is CH3Cl and so this is of 2 marks. Okay. And then they are saying 5 marks. Okay. For step 2, what's going on in step 2? In step 2, nitration is happening. Nitration. Nitration means addition of NO2 plus. So since what we are doing over there, it's not a simple benzene. It's not a simple benzene. It's methyl benzene. It's methyl benzene. And we have to do nitration for the methyl benzene. Now, the thing is that we must know what's the nature of this CH3 group. Is this electron donating or is this electron withdrawing? So alkyl groups are electron donating in nature. So I told you when there is an electron donating group attached on the benzene ring, so it would direct the coming group towards towards 3 positions that are 2, 4, 6 positions, right? So for step 2, draw the mechanism for this reaction, including the formation of a suitable electrophile and the regeneration of the catalyst. Let me revise it. When we were doing nitration, when we were doing nitration. So in a nitration, we did, this is the general equation, the normal equation in which the benzene is reacting with nitric acid in the presence of sulfuric acid catalyst. So the NO2 is attached on the benzene ring. Okay. Um, in the mechanism in step number 1, we have generated the electrophile that was NO2 plus. And in step number 2, the electrophile is attacking on the benzene ring, that is this. And in step number 3, regeneration of catalyst. Okay. So we have to do the same thing in this question. And this is of 5 marks. Number one, we have to write down the equation in which the is generated. I mean, the formation of NO2 plus. So H2SO4 reacts with HNO3 to form NO2 plus and HSO4 minus and water. This equation shows the formation of NO2 plus, right? And then, and then I have phenol. No, sorry, I have methyl benzene, that is this, and this is NO2 plus. It's attacking on NO2 plus electrophile. And as a result of this, since we know that this is a 2,4,6 director, so you can attach any one of the position. Okay, you can attach any one of the position. So, but in the question they have attached NO2 fourth position. So I have to follow the same thing. Okay, I have to follow the same thing. I have to follow the same thing, and then uh, this is the ring. This is hydrogen. This is NO2. The same thing. So you can see right away I would be doing this. Okay, and then hydrogen would be giving its electron to this to balance it. And finally, I got the product. And finally, I got the product. That is this. That's the mechanism. Okay. And then we have to regenerate a catalyst in which, H plus is also released. So H plus will react with HSO4 minus to form H2SO4. So H2SO4 is regenerated, which shows that sulfuric acid was acting as a catalyst. Okay.